Welcome to quantitative aptitude video on square root and cube root from careerright.com. The problems from this topic are frequently asked in placement test, bank, MBA and all other entrance exams. In one way or other, 2 to 3 sums from this topic always appear in exam. Simple tricks explained in this video can assist you to master this topic and help you solve these sums very quickly, giving you an edge in the paper. After this video, you can go to careerright.com, which has 1000 plus practice questions on quantitative aptitude, and take the practice test over there. Let's get started. Before starting with the topic, let's learn a few tricks that would be useful to solve sums related to this topic as well as other topics in quantitative aptitude. The first one amongst the trick is finding the square of a number. Today we are going to learn how to find square of a 2-digit number in just 10 seconds. We know what are squares of numbers between 0 to 10. So today we'll focus on 11 to 99. So any number between this 11 to 99, we are going to find the square in just 10 seconds. Okay, let's take a number, say 37. How do we traditionally find square of 37? We take 37, multiply it by 37. Okay, so 7 and multiply 7 by 37, you get something, then multiply 3, then you get something, and then you add those, and then you get the square of 37. But no need to do all this stuff. Here the trick would help you to find it in just 10 seconds. Now take 37 as an example, which is the nearest multiple of 10 to 37. Okay, then 10 threes are 30 and 10 fours are 40. These two are near to 37. What is the difference between 37 and 30? 7. What is the difference between 37 and 40? 3. Which difference is less, or which is the nearest? 40 is nearest, because the difference is just 3. So discard this. Don't consider 30. Consider 40, which is nearest multiple of 10 to 37. Now when we add 3 to 37, we get 40. So simply subtract 3 from 37. How much you will get? 34, right? So you have 34 over here, you have 40 over here. Simply multiply these two numbers. What you will get? 34 into 40. No need to multiply 34 into 40. Just multiply 34 into 4. Don't consider this 0 right now. What you will get? 34 into 4. 4 fours are 16. 4 threes are 12 plus 1, 13. 136. Now put this 0 over here. 136. 0 plus, now here we added 3, subtracted 3. So take 3 square of 3. What you will get? 1360 plus 3 square is 9. So you will get 1369. Yes, you can check your calculators. This is 37 square, right? I'll give another example. Let's take a bigger number, 94, right? Okay. Now, which is the nearest multiple of 10? We have 90 and 100. 100 is 6 away, and 90 is difference is just 4. So 90 is the nearest multiple of 10. Difference is 4 minus 4. 94 minus 4, we get 90. So 94 plus 4, what do we get over here? 98. So we have 90, we have 98. We just multiply 8. What we get? 90 into 98. Not to consider the 0. Multiply by 9. 9 8s are 72, 9 9s are 81, plus 7 is 88. We add 0 plus, since the difference is 4, we have 4 square, that is 8820 plus 16 would be 8836. Again, you can check your calculators. This is nothing but 94 square. See how easily you got the square. Even when you don't know the formula or the trick, still it will take you only 15 to 20 seconds. Once you practice a little bit, it will surely take you 10 seconds or less only. Okay, moving on to the second trick. Square of a number ending in 5. That means numbers like 5, 15, 25, 35 and so on. So square of numbers which end in 5. Okay, let's take a number, say 85. Okay, let's find the square of this number. How to find? Remember over here in the previous example, what we did was we found the square of a 2-digit number in just 10 seconds. With this trick, you'll be able to find square of a number ending in 5 in just 5 seconds. Let's see how. This is 85. It ends in 5. What is the square of 5? 5 is at 25. Okay, this is done. So 25. Forget 5. Don't consider now. Take 8. What is the next digit after 8? What comes after 8? 9. We know 7, 8, 9. So 9 comes after 8. Okay, 8 into 9 is 72, right over here. Okay, this is the square of 85. 7, 2, 2, 5. You can check the calculator. This is the square of 85. Let's prove it again, or let's see how. This is 25. Let's find the square of 25. Everyone knows what the square of 25 is, because it's a pretty common number. But let's take an example to show that whether this trick is correct or not. Right? 5. Square of 5 is 25. 2, next digit after 2 is 3. 3 comes after 2. 2 3s are 6. So 625. 625 is the square of 25. Right? Again, find the square of 5. You know 25. Now find the square of 15. Okay, what it would be? 5 square is 25. 1. Next digit is 2. 1 into 2 is 2. 225. This is the square of 15. See how easy it was. Just in 5 seconds you can find the square of a number ending in 5. This is applicable to a 3-digit number also. If you take, say, 125. Okay, 5 square is 25. 12 into next digit is 13. 12 into 13. So 12 12s are 144, 156, 15625. This is the square of 125. You can check it out. See, this is another trick which you should remember. It would be very useful. Moving on to the next trick. Square root in 10 seconds. Generally in exam you will have some big number and you will have to find its square root, but you will think that it's lengthy, it's difficult, let's leave it. But you need not worry. The trick which I am going to tell you right now, that would help you to find square root of a perfect square in just 10 seconds. Okay, so even if the number is huge, say 5 digit, 6 digit, you will easily be able to find the square root. The only one requirement which you need for this is you should know the squares from number 1 to number 10. So from 1 to 10 you should know the squares of these numbers. So 1 square is 1, 2 square is 4, that you should know. Okay, let's see what the trick is with an example. Let's say find out the square root of 20164. Now this is a pretty huge number, 5 digit. How to find out? Let's see. Now this number ends in 4, right? Now which number's square ends in 4? Between 1 to 10, which number's square ends in 4? 1 is 1, 2, 2's is 4, then 3, 4, 5, 6, 7, 8. Okay, 8 square is 64, it ends in 4. So we have option 2 and we have option 8. Okay, we have 2 and 8. Now generally we know finding square means say how do we write 5 square? We write 5 square, right? 5 raised to 2. So that means the number 2 is related to square. Number 2 is related to square. So 2 is related to square. So discard the last 2 digits of the given number. Only consider the remaining ones. So we'll not consider 64. We'll consider only 201. Right? Take them over here. 201. Now which is the nearest perfect square to 201? But which is less than 201. So we need to find the nearest perfect square which is less than 201. Let's see which. 10 square is 100, 11 square is 121, 12 square is 144, 13 square is 169, then 14 square is 196, right? 15 square is 225, but this is greater than 201, so you need not consider this. So 196 is nearest to 201 and it is also lesser than 201. So 196 is square of what? 14, right? So our answer should be 144 over here, 142 or 148, right? 142 or 148 is our answer. Let's find out which one, right? Now what is 14 square? 196, right? Now add 14 to it. How much do you get? 210. 210 Is it greater than 201 or lesser than 201? 210 is greater than 201. What does that mean? 201 is less than 210. If 201 is less than 210, that means we have to take the lesser number as square root. Okay, what is the lesser number between 142 and 148? 142. So this is the square root of 20164. Did you get it? I'll give another example that would be helpful. Let's say we take example 16129. Now, which numbers square between 1 to 10, which numbers square ends with 9? Not 1, 2, 3. Okay, 3 is there, then 4, 5, 6, 7. 7 is there, right? 3 and 7. So the two options which we have are 3 and 7. Now, since it's square, discard last two digits, we'll consider only this 161. Now, which is the nearest perfect square to 161 but which is less than 161? So we have 10 square as 100, 11 square as 121, 12 square as 141, 144, 13 square as 169. 169 is greater than 161. So 12 square 144 is less than 161. So we need to consider 12. Write 12 over here, write 12 over here. So we have 123 or 127 as options. Let's find out which one. Now 12 square is 144. Add 12 to it. How much do you get? 156. Okay. So 156, whether it is greater than 161 or lesser, 156 is lesser than 161, our given number. That means that 161 is greater than 156. That means we have to take the greater number as the answer. So 127 is greater than 123. So 127 is the square root of 16129. Understood? See, pretty easy. The trick is very easy. We'll solve such a sum. We'll solve a sum related to this. So you will find it. You will again get an idea what to do. Moving on. Cube root in 5 seconds. Now, just like square root, you can find the cube root of a perfect cube in just 5 seconds. And this trick is much easier than the square root trick. The only requirement which you will have over here is you should know the cubes of numbers 1 to 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are common numbers. You should know, always know the cubes of these numbers, right? It's much better to by heart them right now because in exam they would save a lot of valuable time. Let's take an example and I'll explain the trick. Let's say find the cube root of 205047. Now it looks like a pretty big number. Okay, what is the last digit or how the number ends? It ends in 7. Now which number's cube ends in 7? Let's see, 1, 2, 3's cube is 27. So it ends in 7. So 3's cube ends in 7. So let's write 3 over here. Okay, we got 3 over here. Now there is no other number whose cube ends in 7. Now cube, how do we write 5 cube? We write 5 raised to 3. So the number 3 is related to cube. Whenever we say cube or cube root, we say root of 3 or cube. Cube of 3 is 5 raised to the power of 3. So 3 is related to cube. So 3 digits should be cancelled or ignored. Just like in square root, we ignored the last 2 digits. Here we'll ignore the last 3 digits and consider only the remaining digits. What is this? 250. Now which is the nearest perfect cube to 250 and which is less than 250? We have 1, 8, 27, 64, 125, 216, 343. So 216 is nearest to 250 and less than 250. 216 is cube of which number? 6. So we'll have 6 over here. So answer is 63. See how easy it was. There's nothing to do. It is pretty easy. You just get two numbers and you just write them side by side and get the cube root. Okay, let's take another example. Let's say find the cube root of 185,193. This is again a 6 digit number. Okay, whose cube ends in 3. 1, 2, 3, 4, 5, 6, 7. 7's cube ends in 3. We got 7 over here. Discard the last 3 digits. We have the remaining digits remaining number is 185, which is the perfect cube, which is nearest to 185 but less than 185. We have 1, 8, 27, 164, 125, 216. So 125 is less than 125 is less than 185, okay, and it is a perfect cube, and 125 is the cube of 5. So the answer is 57. See how easy it was. Just remember this trick, it would save really a lot of time in exam. It's pretty easy, you don't have to do anything much over here. Now moving on to questions. Question number 1. Ramesh arranged his 17424 chocolates in such a way that there are as many rows as there are chocolates in each row. How many chocolates did he place in each row? Again, a pretty easy one. It's related to squares and cubes. Let's see how it is related to squares and cubes. Now, we do not know how many rows or how many chocolates are there in each row. So let us assume that, say, this is the first row, and in it Ramesh has arranged, say, n number of chocolates, right? Now if in one row there are n number of chocolates, number of rows also has to be n, because they have given that way there are as many rows as there are chocolates in each row. So number of rows would also be n, right? Number of rows would be n, and in each row number of chocolates are n. Now you know that, say, if there are 5 people standing in one row, and if there are 3 such rows, okay, then how do we calculate the total number of people? This is 5, number of rows are 3, so total number of people would be 5 into 3, 15, right? Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5 into 3, same way over here, total number of chocolates which would be there would be nothing but n into n, that would be n into n, but they have already given total number of chocolates as 17424. So n square is nothing but 17424. So n is nothing but root of 17424, taking square root on both sides. Let's find the square root of 17424 using the trick earlier. Square 4. Square of what numbers end in 4? 2 and 8, right? 2 and 8, it ends in 4. Since it's square, discard the last 2 digits. We have 174, right? So 12 square is 144, 13 square is 169, and it is less than 174. So we'll have 13 over here. So we need to find whether it is 132 or 138, right? Now 13 square is 169. Add 13 into it. How much do we get? 172, 182. We get 182, right? 174 is less than 182. That means we have to take the lesser number. So 132 is the answer. So n number of chocolates in each row is 132. N is equal to 132. See how those tricks are very useful in such cases in solving these sums, right? Moving on. Question number 2. What least number should be multiplied with 384 to make it a perfect square? So we have 384, which is not a perfect square, and we need to multiply it by some number so that it becomes a perfect square. Let's see how to do it. It's very easy. 384, let's factorize it. Let's say divide it by 2. What we'll get? 2 into, say, 2 ones are 2, 18, 9, 192. Again, let's find some more factors to it. 2 into say 4. I'm multiplying again. I'll multiply by 2. Okay, 2 9s are 18, 12, 96. Okay, 2 into 96. It is divisible by 4. So 4 2s are 4 into 4 2s are 8, 16, 24. We have 2 into 4 into, this is again divisible by 4. So 4 into 6, right? So that is 2 into 4 into 4 into 3 into 2, right? So what we have over here, we have, okay, this I'll write over here. What we have is 384 equal to 2 square multiplied by 4 square multiplied by 3 into 2. See, now this is in perfect square, this is in perfect square, this is not a square, this is not a square, these are single numbers, right? So if we multiply by 3 and 2, what will happen? We'll get 2 square into 4 square into 3 into 2. Again we multiply by 3 and 2, right? What we'll get over here? 2 square into 4 square into, this is an extra 3, extra 2. So 3 square into this 2 into 2 square. When the individual digits or the individual factors are square, the number has to be a perfect square. So if we multiply 384 by 3 and 2, that 3 into 2, right, 6, that is nothing but 6, you will get a perfect square. This is how to solve such kind of sums. It is very easy, just find the factors, find the factor which is not in a format of square, right, arrange the factors so that they come into the format of square, find the factors which are not in square, just multiply again those by those factors, and that factors is nothing but the answer. So if we multiply 384 by 6, you will make it a perfect square. How do we get that 6? Because this 3 and this 2 is not into the square format like this 2 and 4, they are only single digits. So if we multiply by extra 3 and extra 2, we will get a perfect, we will get them into this format, right? So we have to multiply extra by extra 3 and extra 2, 3 2s are 6, so extra 6, we have to multiply by 6, then we will get it as a perfect square. Moving on, if square root of 5625 is 75, then root of 5625 plus root of 56.25 plus root of 0.5625 is equal to, again this is pretty easy, you can see that this number gets repeated in various formats over here, right? How to find out the answer? 5625 root is nothing but 75, that we already know from here. Now this is 56.25, there is a decimal point over here, okay? After decimal there are 2 decimal places, right? How many? 2 decimal places. Now we have to find square root. Square is related to which number? Square means 2, right? So if this is the square, okay, and while finding square root, if after decimal there are 2 decimals or 2 decimal places, okay, divide that by 2, how much you will get? 1. So in the square root you will have only 1 decimal place. Now we know 5625 is the square of 75. So let's write 75 from right to left. First we will write the 5 over here and 7 over here. If 75 square is 5625, then 7.5 square would be nothing but 56.25. 75 square is 5625, 7.5 square is 56.25, right? Because we know 7.5 square, since 1 decimal is there after the decimal point, then in the square it would be 2 decimal places when you multiply, right? Same way over here, after the decimal point there are 4 decimals. Now by what should be, since we are finding square root, we have to divide it by 2 because square is related to the number 2. So how many decimal places should be there in the square root? There should be 2 decimal places in the square root, right? Over here. Now 5625 again is the square of 75. So let's start writing 75 from right hand side. First we will write 5, then comes 7, then the decimal point, so here has to be 0. So what we get is 0.75. So 0.75 square is 0.5625, right? See how easy it was. So the answer would be nothing but 75 plus 7.5 plus 0.75, that would be 75 plus 7 is 82.5 plus 0.75, that would be we'll have 5 over here, 2 over here, dot 3, 83.25 is the answer. Did you understand what we did over here? 5625, it is nothing but the square of 75, correct? Now there are 2 decimal places after the decimal point, okay, after the point there are 2 decimal places in the square. So while finding square root, what we do is we take those 2 decimal places over here and we divide by what? We divide by 2. In cube root what we will do? We will take the decimal places and divide by 3, but here we want square root, so we will divide by 2. What we get? Answer 1. So from right hand side we put in 1 decimal point, so we get the answer as 7.5, right? Same way over here, 4 places are there, divide by 2, what we get? 2. So 75 we write over here because 5625 is square of 75, and we add 2 decimal places from right, 1, 2 here, right? 0.75, and just add it. Going to question number 4. What is value of root of 56 plus root of 56 plus root of 56 plus root of 56 and so on? Now for this sum there is a very simple trick which you should follow, right? And you will be able to solve these kinds of sums. Now over here, what is this value? 56. It gets repeated. Let's find factors of 56. What are factors? Factors are various multiplications of 56, as in what are the two numbers of whose product is 56. Say 56 can be obtained by 2 into 28, then 56 can be obtained by 4 into 4 ones are 4, 4 ones are 16, that would be 14, right? Then we'll have 7 into 8, then all these things again it would be 8 into 7, that would be repeated. So that's not useful. So these are the three pairs by which we get 56. Now we have to choose that pair in which the difference between two numbers is 1. Now 28 minus 2 or 2 minus 28 is 26 or minus 26. So this is not useful. 4 into 14 or 4 minus 14 or 14 minus 4, the difference is 10. So this is not useful. 7 minus 8 or 8 minus 7, difference is 1. So this is useful. Take. So we have 7 or 8. Now what sign is here? Plus. Plus means addition. What happens because of addition? Number increases. If it is increasing, if it is becoming greater, take the greater value, right? So plus means greater value. So 8 is the answer. See how easy it was. There's nothing to it. Say if they would have given 56 minus 56 minus 56 minus and so on. What would have you done? You'll take 56. You'll find the pair of numbers that give you 56. 2 into 28, 4 into 14, 7 into 8, right? Now find the pair where the difference is 1. This is not the answer, this is not the answer. We have 7 and 8. We have 7 and 8. Now, since here it is minus sign because of which number decreases or becomes less, take the lesser number 7. So here the answer becomes 7. Minus or subtraction means smaller number. Take 7. See, for plus you take greater number, for minus you take the smaller number. Now there is a third variant to it, and what it is? 56 multiplied by 56 multiplied by 56 and so on. Okay, this goes on continuously. For this, what is the answer? The answer is nothing but 56. Simply write the answer as 56. There is no other thing. The answer is 56. See how easy it was. One small trick and you can solve problems on all three types. Going to question number 5. What will be value of root of 9 by 8 if the value of root 72 is 8.485? Now again this is easy one. We know 72 is nothing but 9 into 8. So let's say we have root of 9 by 8. Let's try to get 72 in the numerator or denominator. Okay, so let's try with numerator. Let's say if we multiply root of 9 by 8 into 8 by 8, okay, multiply and divide by 8, what we will get? Root of 72 upon 64, that would be root of 72, how much it is? 8.485. And what is the root of 64? 8. So the answer would be 1.0606 and so on. So this is the answer. Going to next question. Question number 6. What is value of 6th root of 0.004096? Generally we have cube root, we have the square root, but this is not that, this is the 6th root. Let's see how to solve it. Okay, now whenever we have something like say cube root of 11, so we can also express it as 11 raised to 1 by 3. Same way, this can be written as 0.004096 raised to 1 by 6. Also, say if we have a number like 5 raised to 8, okay, what we can write? 8 can be written as 4 into 2, right? So we can write 5 raised to 4 into 2, right? Same way, since 8 can be written like this, 1 by 6 we can express it as 0.004096 raised to 1 by 3 multiplied by 1 by 2. See, we wrote 1 by 6 as 1 by 3 into 1 by 2. So we got it as cube root and square root. So this number raised to 1 by 3 is cube root, and whatever answer we will get, we will take out the square root of that. Now let's find the cube root first. Now let's forget all the decimal points and zeros, consider 4096, right? So we have seen how to find cube root in how much? 5 seconds. This ends in 6. So that means 6 cube of 6 is 216. So the one part of this would be 6. Neglect the 3 digits at the last since it is cube root. Consider 4. Perfect cube which is less than 4 is nothing but the cube of 1, right? So 1 would be the answer. So answer would be 16. So this is nothing but the cube of 16. But we have decimal points. Now how many decimal places are there? There are in total 6 decimal places, and since we are taking out the cube root, we have to divide by, cube root is related to the number 3, so we have to divide it by 3, and what we will get over here? 6 divided by 3 is 2, so we have to consider 2 decimal places. This is the first, this is the first, and this is the second. So 0.16 is nothing but the cube root of 0.004096, and now we have to find its square root. Again, forget the decimal point, forget the zeros, consider 16, right? For 16, what is the square root of 16? 4, because 4 square is nothing but 16. So answer is 4. Again, how many decimal places are here? After the decimal point, there are 2 decimal places, 1 and 6. So 2 decimal places are there, and see, 2 decimal places are there, and since we want square root, we divide by 2 and we get 1. So the answer comes out to be 1 decimal place, so that would be 0.4. So answer of this is 0.4. See how easily we got this. Question number 7. Find value of 1 upon root of 25 minus root of 18 if root of 2 is 1.414. Now this might look a little bit of complicated sum, little bit of complex sum, but this is not. Because now I am going to tell you a small trick that would help you solve sums which have root in the denominator. Now this is 1 upon root of 25 minus root of 18. We can directly solve this sum by substituting these values, by reducing this 18 and get, because root of 25 is 5, okay? Root of 18 we can write 9 into 2, so 3 root 2, and we can put this value and then divide and find the answer. But what happens is that dividing 1 by some fraction or something like, or by some decimal, it becomes very difficult. So how to easily calculate the answer? Let's see. 1 upon root of 25 minus root of 18, we just need to rationalize it first. Okay, we need to rationalize it first. Rationalize will help you get rid of this root signs in the denominator. What does rationalization mean? What it means is we have to multiply by the same root sign or the same number, and multiply and divide by the same number, only the sign must be opposite. So if we have minus over here, while rationalizing, while multiplying and dividing, we will have plus. Okay, let's see how exactly. By solving, you will understand what I am about to tell you. Root of 25 minus root of 18, this is given, and by rationalizing, what we will get? 1 upon root of 25 minus 1 upon root of 18, multiplying and dividing by root of 25, root of 18, root of 25, root of 18. Now in rationalization, we multiply and divide by this same number, only the sign is opposite. So here if it is minus, we will have plus over here. So if the number was like say root of 25 plus root of 18, then while 1 upon, then while rationalizing, what we will have? We will have root of 25 minus root of 18 and root of 25 minus root of 18. Okay, so this sign is exactly opposite. So remember, sign is opposite and we have to use the same number. Now what happens is that because of this, what we get? Root of 25 plus root of 18, and here we have the format a minus b multiplied by a plus b, and we know the answer to this as a square minus ba plus ab minus b square. So this gets cancelled, so we get a square minus b square. So what we have over here is nothing but root of 25 square minus root of 18 square. Okay, so root of 25 is nothing but 5. Okay, root of 18 can be written as 9 into 2. Over here, this root sign and this square gets cancelled, so we have 25. Same way we have 18. What we get is 5 plus root of 9 is 3 root 2 upon 7. Now we know the value of root 2, what it is? 5 plus 3 into 1.414. They have given it divided by 7. So what is the answer that we get on calculating? We get 4.242 divided by 7, that is 9.242 divided by 7, that is 7 ones are, then 2, 22, 7 threes are, 2s are 0 and so on. So 1.320 is the final answer. Moving on. Question number 8. Square of difference between two numbers is 9, while the sum of squares of those two numbers is 225. What is their product? Again, an easy one. Square of difference between two numbers. Let the two numbers be A and B. So difference between two numbers and their square is equal to 9, while the sum of squares of those two numbers is 225. Sum of squares of these two numbers is 225. Now take a look at this. This is A minus B the whole square, which can be written as A square minus 2AB plus B square equal to 9. So A square plus B square, we know it is 225. So what we have, 225 minus 2AB equal to 9. So 225 minus 9 is 116 equal to 2AB. AB equal to 2 5s are 10, 58. They have asked what is their product. A into B is 58. Moving to question number 9. What is the smallest number with which 5400 may be multiplied so that the product is a perfect cube? Again, like a perfect square only, we have to solve this. We have 5400. Let's find the factors. 54 can be written as 2 into 27, 100, right? So what we can write is 200 into 27. 27 we know is a perfect cube because 27 is cube of 3. 3 cube is 27. So we have 3 cube into 200. Now 200 is not a perfect cube. Let's see how to make 200 a perfect cube. What are the factors of 200? 200 is nothing but 2 into 100, that is 2 into 2 into 50, or we can write 2 into 2 into 2 into 25. So we have 2 cube into 5 square, okay, or 5 into 5. Now 2 again is a cube. So this is in cube format, 3 is in cube format. Only the thing which is not in cube format is 5. There is one 5 missing. So if we multiply this by an extra 5, okay, this is an extra 5, then what we'll have? We'll have 2 cube and 5 cube. So just like the square sum, we just need to multiply 5400 by an extra 5, then we'll get a perfect cube. So answer is 5. Question number 10. The value of cube root of 0.00027 into 0.008 is again very easy. Let's take this. 27 is the cube of 3, so the cube root for 27 would be 3. Again 8 is the cube of 2, so cube root of 8 would be 2, right? Now there are 1 2 3 4 5 6 decimal places. We want cube root, so divide by 3. Okay, 6 by 3 is 2, so 2 decimal places should be there in the cube root. So for this it would be 0.03 multiplied by, over here there are 3 decimal places, divided by 3 will get 1, so this would have decimal place 1, so it would be 0.2, so it would be 0.03 multiplied by 0.2. The answer would be 0.006. So see how quickly you found out the answer over here with those small shortcut tricks which you learned at the start of the tutorial. This is very easy to calculate. Question number 11. Which is greatest among the following numbers? 2 root 2, root 7, 2 root 3, root 5. Okay, here there is a very small trick, very easy trick to remember. Now here we see everything is in root. Root, say if there is root of 8. So how do we write root of 8? 8 raised to 1 by 2. So try to bring everything in this format. Okay, so let's start with this. This is 2 root 2. So whenever this 2 gets into this root sign, it will become square. So 2 square would be 4. So 2 root 2 can be written as 4 into 2 root of 8. This is root of 7. This is nothing but 2 will go inside, it will become 4. 4 3s are 12, root of 12, and this would be root of 5. Now everything is root, which can be written as 8 raised to 1 by 2, 7 raised to 1 by 2, 12 raised to 1 by 2, 5 raised to 1 by 2. When these powers are same, the greatest number over here is the greatest. So amongst 8, 7, 12 and 5, 12 is the greatest. So 12 raised to 1 by 2, that is root 12. That is 2 root 3 is the greatest number. If they ask you what is the smallest number, just find which is the smallest number amongst this. 5 is the smallest number. So root 5 is the smallest. Okay. But here we do not need smallest. Here they have asked what is greatest among. So 12 raised to 1 by 2, that is 2 root 3 is nothing but the greatest number amongst all these 4. See how easy trick was. Question number 12. What should come in place of question mark in 90 upon question mark is equal to root of 64 upon 729 the whole raised to minus 1 by 3. Now this looks complicated, but let's see how to solve these sums very quickly and easily. We have root of 64 upon 729 the whole raised to minus 1 by 3. Now we know root we can write as 1 by 2, so this can be expressed as 64 upon 729 the whole raised to 1 by 2, okay, the whole raised to minus 1 by 3. This is nothing but 64 upon 729 the whole raised to 1 by 2 multiplied by minus 1 by 3. Now we know we can exchange the positions over here. So what we will get, 729 into 1 by 3 multiplied by, we can have minus 1 by 2. Okay, so now we need to find out the cube root of 64 upon 729. That's pretty easy. Cube root of 64 is nothing but 4, and cube root of 729 is nothing but 9, because 9 cube is 729. So what we will get over here, 4 upon 9 raised to minus 1 by 2. Now whenever there is a minus sign in the raised to power, okay, over here, what does that mean? That means we just need to flip this fraction. For example, if I have 1 by 2, okay, or let's say take another fraction. If I have 5 upon 4 raised to 1, okay, so this is nothing but, if you take 4 up and 5 down, if you invert it, you will simply write raised to minus 1. If you have 4 raised to 5, 4 upon 5 raised to minus 1, then if you flip it, 5 upon 4, it would, minus 1 would become 1. Same way over here, if you have 4 upon 9 raised to minus 1 by 2, if you flip it, what you get, 9 upon 4 raised to 1 by 2, minus sign simply becomes positive, minus sign also flips. So what is the square root of 9 by 4? That is nothing but 3 by 2, because square root of 9 is 3, square root of 4 is 2, that is equal to, okay, this is 3 by 2. So that is equal to 90 upon question mark is 3 by 2, okay, 3 into 30. So question mark would be 30 into 2 is 60. So 60 should come in place of the question mark. See how easily with small tricks and tips and shortcuts you can solve all the sums which are related to squares, square roots, cube roots, etc. With this, we come to the end of this video. If you like this video, please give it a like and share it with your friends. You can leave your comments and suggestions for us in the comment box below. You can even tell us about any specific videos that you would like us to develop for you. We would be rolling out more such videos and tutorials, so subscribe to our channel and stay updated.